Okay, this is my notes. Okay, whichever I have. Okay, uh, this is actually the notes which I made my during my BE. Okay, and it is completely taken a reference from this the Krishna Raju textbook. Okay, so in your examinations, either it is online, offline, or any competitive exam, it is the questions will be from the Krishna Raju textbook, which just now I have shared you in the group. Okay, so this note is completely uh, took the reference from that Krishna Raju book. If you want, you can refer this one. I will share the PDF. If you are not interested to read everything, whatever in the textbook, I will share these notes, my notes. If not, if you want, you can use your TechMax, Techno, etc. Whatever, it is up to you. So so we have seen all these things: advantages, disadvantages, what you mean by pre-stressing, pre-tensioning and post-tensioning. Okay, the stages. Okay, then the classification, post-tensioning, how it is made, wedge actions we saw. Okay, fairness, Grifford, and Anderson, Mangal, Belton systems. Okay, need for high grade of concretes. Yesterday we have discussed it. Durability property of hard concrete. Okay. Next, properties of pre-stressing steel is that we need high steel. High bond is required. That is bond between steel and concrete. Okay. Adequate ductility. Low relaxation due to reduced losses. Okay. In the next chapter, we will see about the losses. Bendability, minimum corrosions. Okay. So we have seen about this one also. Okay, if it is your offline mode, okay, he will ask to draw and explain about the different types of anchorage systems. Okay, so today we will see about the new thing, that is analysis of pre-stressing members. Okay, how we have to analyze. So we have three concepts, that is concentric tendon, eccentric tendon, and pre-stressing with dead and live load. Okay, so we will see detail one by one, and the numericals on these are very simple. Here only we have to determine the bottom stress and top stress. Okay, you can call it as FB and FT. It is a standard notation in the textbook, or in your, if you are referring your techno, it is sigma B and sigma t. Okay, so whatever, if it is your offline mode in designing, okay, in designing subject, whenever he said to design anything, or whenever he said to solve the problems, I don't know whether in previous semester the sirs have told you or not, but whenever you start solving, if you are using any different notations, they're like FB, sigma, FCK, FT, you have to write it. What do you mean by FB? FB is nothing but the bottom stress, FCK is the characteristic strength, FT is the stress at the top, because the different colleges will use some different reference boxes. Okay, there will be a different notations. So if you want to fetch the full marks, just what you do, you write down what you mean, what are the notations that you are using. Okay, coming to the concentric tendon. What do you mean by concentric tendon? See, this is your beam. I will call this is as a beam. Okay, this is your LS, that is longitudinal section, and this is your concentric stress, sorry, cross section. Okay, here you can see my tendon is exactly passing at the center, at the neutral axis. So this one we call it as a concentric tendon. In cross section you can see the tendon is at this point. Therefore stress or pressure, it is given by force upon area or load upon area. So if your question is like this, prestressing member for tendon, 8 mm diameter, etc., has carrying a load of say 150 kilonewton, and the length and width of the beam, okay, or the size of cross section, say it is 200 by 300. He will give like this, and he will say determine the stress. So directly question, in MCQs it will be a direct one for you. He will say determine the stress, that is load upon area. Okay, and the unit will be Newton per mm square. And remember one thing, the load will be in terms of kilonewton. We have to convert it into Newton, that is 10 power 3, and area it will be in terms of mm. Okay, therefore the resulting will be in terms of Newton per mm square. So this is about the concentric tendon. Then what about eccentric tendon? So this is my neutral axis. Okay, and the tendon, you can see it has an eccentricity of say 50 mm, E equals to 50 mm. Okay, so and he will give the cross section. Okay, and the direct stress, this is the direct stress. Direct stress, it is given by P upon A, and the stress due to bending moment, it is P multiplied E divided upon Z. Okay, ZB means bottom, and ZT, it is at the top, modular section. Okay, how you calculate modular section? That is I upon Y. In last class I have said that go through some basics, how to calculate the I value, that is moment of inertia, which is in terms of mm raised to 4, and modulus section, that is mm cube. Okay, so here not that much problem is there. So here one thing you have to remember, that very important thing. See, if you closely observe the figure, the direct stress at the bottom it is plus, at top it is plus. Therefore, if I take only the bottom one, okay, stress at the bottom, so I will see only the thing which is below the neutral axis. Okay, here you can see it is plus, therefore it is plus P upon A. Okay, and if you see the stress here, it is also plus P into E upon ZB. Therefore, this will be the formula for calculating the stress at the bottom for the pre-stressed concrete. Similarly, if I see the things above the neutral axis, the stress at the top fiber, it is given by, here also it is plus, therefore plus P upon A, and here you can see it is a negative, therefore this is minus P into E upon Z T. Okay, this will be the formula for your top fiber. Okay, so better you sit with pen and paper, calculator, we are solving the numerical, so be fast. After once I finish up to here, I will give some time to copy down the formulas. So copy down the formulas and we will solve the numerical on these things, and nothing to worry, there are directly questions, just substituting the values. And if it is I section or C section, then you have to determine the value of Z. It is very difficult. Means if you know the basic means, again it is very easy. Okay. So remember, for the eccentric tendon, the formula is like this, and this is without loading. Loading. Whether it is visible or not, just comment me yes or no. Whatever. Was it visible? Okay. Others, was the PPT was visible to you correctly? Okay. So this is without loading. The stress at the top fiber, which is equals to P upon A minus P into E divided by Z T. For the fiber, which is equals to P upon A plus P into E upon ZB. Okay. This is the formula. Or this Z can be simplified as, for example, P of F upon B. We know that Z equals to I upon Y. Okay. Therefore, FB equals to P upon A plus P into E divided by I upon Y. Okay. You have to, if it is your simple rectangular, then you will directly get the value of Z. If it is your I section, okay, I section or T section or C section, etc., then here we have to determine the depth of the neutral axis, and also you have to determine the modular moment of inertia. Okay, then only you will get I upon Y. Okay. Now, pre-stressing with dead load and live load. Okay. See here, see, we can see there is a neutral axis at this point. Okay. And pre-stressing force is at the, say, at an eccentricity E. Okay. And this is a cross section, that is B upon D. Now, here you can see this is the cross. Okay. Here is our tendon, and we are applying a pre-stressing force of, say, P kilonewton. Okay, this is our direct stress, this is our bending stress, that is P into E upon Z upon B, same as this above one. And additional thing is that here we have the load. Okay, the load is that one we have dead load and another one is live load. Therefore, the movement will be with respect to dead load and live load. We have to calculate the dead load, and also the live load will be directly given, either it is 2 kilonewton, 3 kilonewton, etc. Okay, so the movement with respect to dead load and the movement with respect to live load, we have to calculate it. Okay, mg represents the movement due to dead load, that is gravity load, and mq represents the movement due to live load. Okay, so the formula will be ft equals to, if I am talking about the top fibers, Here you can see Ft equals to E upon A minus E into E upon ZT, okay, plus mg upon ZT plus mq upon ZT. Otherwise, if you want, you can combine it and write it like this. Okay. Similarly, for bottom, it is P upon A plus P into E upon ZB minus mg plus mq upon ZB. If we want to split and write P upon A, this is plus P into E upon ZB minus mg upon ZB minus mq upon ZB. Okay. Here the important thing is that remember where you get the positive sign and where it is the negative sign. So if you are taking the top fiber, here we have P upon A minus P in minus, it is here, and here we have plus. Okay. So remember any one, you don't get confused. Remember any one. For top fiber, the middle one will be, that is the bending stress will be the negative, and the remaining parameters will be in terms of positive. Okay. At the bottom, here it is P upon A plus P into E upon A, and this is negative. Okay. At top, the second one is the negative, and at the bottom, the third one is negative. Okay. So take pen and paper with along with calculator, write down this formula, write down this formula, and write down this formula. Or if you want, you can take the screenshot, but we have need to solve some problem. So write down this formula. I will give 1 minute. Be fast. The notes will be shared with you. I hope you have completed this one. So we will see one numerical, and the question is like this. Okay, simple one. A concrete beam of rectangular section of 150 by 300 mm. So he has given the cross section, that is 150 by 300. Okay, pre-stressed. Okay, he said pre-stressed by 4 high tension wire of diameter 5 mm, stressed to a 1200 Newton per mm square. Okay, stress he has given, that is 1200 Newton per mm square. The wires are, here he has not given the load. Okay, we have to calculate the load. And the wires are located at an eccentricity of 50 mm. E he has given. Okay, here how many wires are there? 4 wires are there, and it is located at an eccentricity of how much? This is a neutral axis. It is locating at a 50 mm. Find the stress. Find the stress in the member. Okay. So the first what? In designing subject, the first important thing is that we have to draw the figure, okay, with respect to the given data, and also write down the given things, okay. So here we can see this is a 150 by 300 mm, okay. Therefore, the neutral axis will lie at exact center because this is a rectangular section. The neutral axis will be at the center. Therefore, 150 here and 150 below. Okay. Then he says that the four bars are high tension wires are located at an eccentricity of how much? 50 mm. Okay. This is the 50 mm. Here we can see. I will change the color. Eccentricity, how much it is there? It is 50 mm. Okay. So we have the formula that is Ft equals to stress at the top fiber equals to P upon A minus P into E upon Z, and Fp equals to P upon A plus P into E upon Z. Okay. But here you can see he has not given the value of P. Okay. Here he has given the value A is given, okay, again P is not given, E is given, and Z is not given. So the thing is that we have to determine the P, and we have to determine the value of Z, and also we have to determine the stress at top and bottom. Okay, so how you determine the first one, that is P? We need the load. He says that you know that stress equals to what? Load upon area, correct? But here he has given the bars are stressed to how much? 1200 Newton per mm square. Therefore, write down 1200 Newton per mm square. We want to determine the value of P. Okay. A. A is here, it is area of steel or wire. Okay, not about the concrete, it is the area of the steel. So here you can see he says that 5 mm dia. Okay, and how many bars are there? 4 bars are there. Therefore, number of bars multiplied by, how you calculate the area of the bar? That is pi d square by 4. What is the diameter of the bar? It is 5. Okay, pi d square by 4. Therefore, this 4 get cancelled. Pi 5 square. You what to do? Just cross multiply and determine the value of P. So we got P equals to 1000 stress multiplied by area, which is equals to 94247 Newton. Okay, and it is not necessary to keep in terms of kilonewton. Why? Because Ft and Fb will be in terms of Newton per mm square. Okay, so directly we have got in terms of Newton. Therefore, it is not necessary to keep in terms of kilonewton. So we have determined the value of P. Then we have to determine the value of Z. How we determine the value of Z? As this is a symmetric rectangular section, the stress at the top and stress at the bottom will be same. You know that I equals to, for rectangular section, modular moment of inertia you have already learned. Moment of inertia for rectangular, it is BD cube by 12. Correct? I value is how much? BD cube by 12. You have two options, that is Z can be calculated by I upon Y. One thing you can calculate I, substitute here, and Y value will be the neutral axis, that is 150 mm. Okay, you can do like this, or directly we have the formula, that is Z T equals to ZB will be equals to BD square upon 6. Okay, you can if you use this formula also, no problem. This is also correct. If you use this one also, it is also correct. Here it is little bit time consuming because you have to determine the value of I, and again I it is given by BD cube by 12. Therefore, For rectangular section, ignore this one. So directly go for this BD square by 6. Therefore, ZB equals to how much? BD square upon 6. What is width? It is 150 multiplied by depth. How much it is? 300. Therefore, 300 square upon 6, which is equals to 2.25 into 10 power 6 mm cube. Okay. See, remember one thing, I will be in terms of mm raised to 4 and Z will be in terms of mm cube. Units are very important. Now, you have got the value of P. A is directly given. A is how much? Area of the concrete, that is 150 by 300. Okay. It is not necessary to calculate. You can directly substitute. E it is directly given, and you have E you have calculated, and Z you have calculated. Okay. Now substitute in the formula, that is Ft equals to, what is the value of P? We have just calculated here, that is 94247 upon area. Area is how much? That is 150 multiplied by 300. Okay. Now this is top fiber, therefore the stress will be minus. P is how much again? 94247 multiplied by E. E here is directly given, that is 50 mm. Okay, divided by Z, just now we have calculated here, that is 2.25 into 10 power 6. Okay. Therefore, on calculating here, you will get the value of top fiber as 0. Similarly, go for the bottom fiber, that is FB equals to 94247 divided by 150 multiplied by 300 plus, okay, 94247 multiplied by my 50 divided by 2.25 into 10 power 6. So you are getting 4.18 Newton per mm square. Okay, that is compressive stress at the bottom fiber. So we have calculated the top stress and the bottom stress. So this was a simple numerical which we can possible of getting in MCQs. So anybody having doubt in the first problem? Comment Y or N. Anybody having doubt? If you have comment yes, if not comment. Anybody having doubt? Anybody having doubt? No, sir. Okay. Now we will go for the second type of numerical, that is a rectangular concrete beam of cross section 300 by 200 is pre-stressed by means of 15 wires. Okay, it is pre-stressed by means of 15 wires of 5 mm diameter. Okay, how much? 15 numbers of 5 mm diameter. Okay, and located 6.5 centimeter from the bottom of the beam. So directly, instead of giving directly E, he has given, so from the bottom it is located at how much? 6.5 centimeter from the bottom of the beam. Very important, read the question clearly. And the 3 wires of a diameter 5 mm. Okay, see here, sorry, 3 number of 5 mm diameters located at top. So here, if this is your nodal axis, here 15 bars are there and here 3 are there. Okay, so and he has also given the locations of that. Assuming the pre-stress in the steel as 840, Okay, most important, he has given the stresses as 840, stress in the steel, 840 Newton per mm square. So calculate the stress at the extreme fibers of the middle span section or when the beam is supported on its own weight. Okay, so here he is saying about the dead load or dead weight, and the span of the beam is how much? 6 meters. And if uniformly distributed of 6 kilonewton per meter is imposed, and also he has given the live load of 6 kilonewton per meter. Evaluate the maximum working stress in the concrete. The density of the concrete is 24 kilonewton per meter cube. Okay, so if you see here, okay, this is the with loading. Here we have to calculate the dead load and live load. Live load he has directly given, that is 6 kilonewton per meter. Okay, with the help of the dead load we have to calculate the mg, and we have to calculate mg and mq, and we have to substitute in the formula. Also he has not given the value of p, instead he has given the stress. Okay, that is 840 newton per mm square. Okay, so here we are using this formula. Okay, stress due to dead load and live load. So the first important thing is that you have to draw up to the given thing. Okay, whatever he has given, just draw according to that one. So this here you can see 200 by 300 mm beam. Okay, he is saying that 15 bars of 5 mm dia located at 6.5 centimeter from the bottom. So here how many bars are there? 15 bars are there, and the diameter of that bar is how much? 5 mm. Okay, 15 numbers of 5 mm dia bars. Okay, and he says that it is located at 65 mm or 6 from the bottom. Okay, so our representation is in terms of mm. So what I'm doing, I'm writing 65 mm. So from the bottom fiber, here it is 65. Okay, and here the basic knowledge is most important. If I draw here, my total depth is how much? 300. If I draw the neutral axis, this will be 150 and this will be 150. Okay, and my bars are located at how much? At what distance? 65 mm. Okay, therefore what is the eccentricity here? That is 150 minus 65 mm. Okay, so keep it in the mind, don't get confused. Okay, sometimes he will say that is the bars are located or tendons are if he located at the from the bottom fibers or soffit. Okay, remember it. But here in our case the steels are located at the top and also at the bottom, so we have to determine the centroid of the prestressing force. Okay, exactly where the prestressing force is acting. Suppose if he has not given this top bars, okay, therefore your E will be directly 150 minus 65. Okay, but here he is also mentioned at the bars are also at the top one, so we have to find the CG. Okay, so how we will find out that one? That is before going that one, so here he says that 3 wires of diameter 5 mm located at 2.5 centimeter from the top. So what you do, just mention here, correct? And how much he is saying, that is 25 mm or 2.5 centimeters, correct? Then he has given the span of the beam, that is how much? 6 meters. And also he says that the live load of 6 kilonewton and dead load of 6 kilonewton per meters. Okay. Now, with respect to all given things, so what we will do, we will first find out the CG of the pre-stressing force. Why we are finding the CG of the pre-stressing force? See, here there are three persons. Okay, just to make you understand in a simple language, here there are three peoples, and here there are 15 peoples. If I draw like this, okay. So you know the rope pulling game, okay. So here three peoples are pulling the rope, and here 15 peoples are pulling the rope. So the if I tie some ribbon or any tag here, uh, usually in Olympics or in games you have seen, or in childhood also you have played this game, tying some group, one group will be standing here, another group will be standing here, and you have to pull the rope. Okay, means that you have to bring the person here, or you will be taken from here to here. So here we have to determine the effective force. See, here three persons are pulling the rope, and here 15 persons are pulling the rope. So we want to determine where this is my center, correct? Whether this ribbon or any tag is going this side or going this side, or where it is going to stop. Okay. So because of that only we are determining the CG for the pre-stressing force. Therefore, how you determine that CG? That is y equals to, first we will take the bottom, that is 15 numbers of, what is the distance? It is 65 plus 3 number of bars, and what is the distance? It is either you take from bottom or you take from the top. So I'm drawing my reference axis like this. Okay, in engineering mechanics you have already learned this one, drawing the reference axis at the socket of the beam. Okay, from here to here it is 65, and from here to here it is 300 minus 25, that is 275. This is 275. And how many bars are there? 18 bars are there. Therefore we have got the CG as how much? 100. So the effective pre-stressing force is acting at this point, correct? So, and what is this 100 mm from where it is? From the bottom. Why from the bottom? We have taken the reference from the bottom. Okay. So it will be, the pre-stressing force will be 100 mm from the soffit or the bottom fiber. Okay. This is how we calculate the one. And one thing, if he has not given the above fibers, sorry, above bars or the tendons, then our procedure will be the same one. That is E equals to 150, means this half minus this 65, which is equals to 85 mm. Directly we have calculated the E, but the thing is that he has given the top and the bottom. Now, once you calculated the value of y, okay, here you have to determine the eccentricity. I will draw bigger diagram here. Okay, this is your effective pre-stressing force. Okay, and this distance is how much? 100. Okay, therefore this E will be how much? E will be equals to 50 mm. Okay, remember this one. Then pre-stressing force, in previous problem like this, here the force is not given, P is not given. So what we have to do, we have to determine the value of P. How we will calculate? We know that stress equals to load upon area of the steel, correct? So we need P equals to stress into area. Okay, therefore P equals to, what is the stress he has given? 840. In question he has given 840 multiplied by how many bars are there? 18 bars are there. Stress equals, sorry, P equals to stress into area. Stress how much he has given? 840 multiplied by area of the steel. How many bars are there? 18 bars are there, multiplied by pi d square upon 4. After calculating, you will get the force, that is total pre-stressing force is how much? That is the value of P is how much? 3 into 10 power 5 Newton. And it is not necessary to calculate, convert it into terms of kilonewton. We will keep it in terms of Newton only. Now we have to determine the value of A. A is how, what? That is 300 by 200. 200, 300. So you will get the area. It is not necessary to, again, it is not necessary to calculate. Okay, directly you can substitute. And I value, you can, it is not necessary to calculate the I value, you can directly calculate BD square upon 6, or if you want to calculate I equals to BD cube upon 12. Okay, then you have I equals to Z equals to I upon Y. Okay, therefore you have to calculate the value of Z. Okay, then the most important thing is that if I come to the previous slide, that is we have to determine mg and mq. Okay, before determine the mg and mq, we have to determine the dead load and we have to determine the live load. Okay, now again very simple, don't get confused. The starting numericals I will explain slowly, then you have to pick up it. Okay, so dead load, how you will calculate? You have already learned in the SD2, that is if your beam size is 300 by 150, therefore it will be 0.3 by 0.15 by density, correct? So similarly we are doing here, the self weight of the beam is, cross section how much it is? 300 by 200, and density he has given, correct? Therefore density, after calculating the self weight, how much we have got? We have got 1.44 kilonewton per meter. Okay, remember you are getting in a kilonewton per meter. Then self weight moment, that is we have got the dead load. Then we have to calculate the movement with respect to dead load. Okay, for example, this is your beam. Okay, so sorry, the load. Okay, then we have to determine the movement with respect to this dead load. Okay, in SA1 we have already learned this one, how to calculate the movement, and we know the formula, that is for uniformly distributed load it is WL square upon A, correct? Therefore mg with respect to self weight. Okay, and if you are simply supported beam subjected to UDL, the maximum moment it is given by WL square upon 8. Okay, what is W here? W is nothing but your dead load, correct? So substitute here WL square upon 8, that is 1.44. L is how much? 6 meters. Okay, substitute, divided by 8. So we have got movement with respect to dead load, that is M. First I will write down Wg, that is dead load. How much I have got? 1.44 kilonewton per meter. Then mg, that is movement with respect to gravity load, dead load. Okay, that is we have got 6.48 kilonewton meter, correct? Similarly we have to determine the live load. Okay, live load he has directly given, that is 6 kilonewton per meter. Okay, directly he has given, that is 6 kilonewton meter, and also he says that The live load is UDL. Okay, it is saying uniformly distributed load. This is a UDL. Again, for UDL, the moment will be WL square upon 8. What you do? Just substitute here WL square upon 8. We have got the live load. Sorry, movement due to live load, and this is movement due to dead load. Correct? Therefore, you have got all the parameters. Substitute in the formula, that is Ft equals to P upon A. P we have already calculated here. Okay, 3 into how much? 10 power 5 upon area. How much it is? 200 by 300. Okay, and it is minus. For top fiber, middle one is minus. Again, P into E. P is how much? 3 into 10 power 5. What is the eccentricity? The effective pre-stressing force is here, and this one we have calculated, that is 50 mm. Okay, therefore 50 divided by Z. How much it is? For rectangular section, top and bottom will be the same. This is 3 into 10 power 6. Now plus we have formula mg plus mq upon zt. Okay, what is the value of mg? I will write it here. Mg, it is here, that is 6.48. Now the important thing is that here it is in terms of kilonewton meter. Therefore what you have to do, 6.8 multiplied by 10 power 6, which will be in terms of Newton per mm. Okay, divided by Z, that is 3 into 10 power 6, plus the denominators are same, so I'm writing it here only. Live load is how much? 27. That is 27 into 10 power 6. Okay, so this is how you substitute the value of FB and FT. Okay, similarly we have to calculate the FB. I will write it here. FT, P is how much? 3 into 10 power 5 divided by 200 into 300, then plus P into E upon Z. Okay, P into E upon Z. Okay, minus mg is how much? 6.48. It is in terms of kilonewton meter. Convert it into Newton per mm. 3 into 10 power 6 minus, what about live load? It is 27 10 power 6 upon 3 into 10 power 6. So we have to calculate the top fiber and the bottom fiber. Okay, so this one, how to write in a simplified way, I will tell you. So here you can see this is 6.8 and minus 27. So what you can do is that minus 6.48 plus 27 divided by 3 into 10 power 6 into 10 power 6. If you write in this way also, it is correct. Okay, or if you write in this way, it is also correct. Otherwise you can write it minus 6.48 plus 27 divided by 3, which is equals to 10 power 6 by 10 power 6. This get cancelled. Okay, so it is up to you. So after substituting the values, you will get the answers. Okay, so here I have made calculated the direct stress, individual things. Okay, so direct stress is nothing but P upon A. Okay, bending stress is nothing but P into E upon Z. Okay, then stress due to the weights are mg upon Z. This is due to live dead load, and stress due to live load, it is like this. Okay, so you can calculate like this also. So anybody having doubt here, be fast, comment yes or no. Anybody having doubt? What others? Only Avinash is commenting. Good. So if you understand these two problems, then up to the third unit, okay, uh, you will be a little bit familiar with solving the numericals, because these formulas are the okay these formulas are the very basics in the research concrete. Okay, next we have little bit bigger problem and little bit headache one. Okay, so just I will give a glance. What is the time? 11:41. Okay, I will explain this one last numerical. Okay, remaining I will take in the next class. Okay, and one more thing, in any designing subject, okay, you have to read the question at least for twice. Okay, you have to read the question at least for the twice, because at a single stretch reading this whole question, you'll forget some important things. Okay, so at least read twice. Okay, the question is like this: an uns sorry, an unsymmetrical I section beam. Remember, unsymmetrical I section beam is used to support an imposed load of 2 kilonewton per meter. So live load he has given, that is 2 kilonewton meter over a span of how much? 8 meter. It means that we have to calculate the dead load, live loads, and moment due to dead load and live load. Okay. The sectional details are top flange. What do you mean by top flange? This is the top flange. Okay, this one is the web, and this is the bottom flange. Therefore, the section details are top flange of 300 mm wide and 60 mm thick. The bottom flange 100 mm wide and 60 mm thick, and the thickness of the web is how much? 80 mm. Therefore, the top flange web and the bottom flange he has given. Overall depth of the beam is how much? 400. So he has given this overall depth, that is 400 mm. Now at the center of this span, one second, at the okay, at the center of this effective pre-stressing force of 100 kilonewton. Okay, so here he has given directly the force. Okay, he has given directly the force of how much? P equals to 100 kilonewton. E is located at 50 mm. Okay, from the soffit. See, he has not directly given the eccentricity. He has said that the pre-stressing force or the cable, it is located at how much? Here in figure you can see it is located at 50 mm from the soffit, or the from the bottom of the beam. And he says that estimate the stress at the center of the span, okay, of a beam for following conditions. Most important, for the following load condition, that is, the first one is pre-stress plus self-weight, pre-stress plus self-weight plus live load. Okay, if I write the formula, so for this one the formula will be, I will write out any one. Okay, Ft equals to P upon A minus P into E upon Z plus M, only self weight he is asking, therefore mg upon Z. Okay, he is not asking about the live load, but here he is asking about the live load, that is Ft equals to P upon A minus P into E upon Z plus mg plus mq upon Z. Okay, Now, so the most important thing is that you have to draw the figure up to the given thing. So he says that the top flange is of 300 wide and 60 thick. Okay, and web he has given. Okay, this is the web. He has given how much? 80 thick. Now, and the bottom flange he has given how much? 50 sorry, 60 thick and 100 wide. Correct? And he has given the overall depth. Now, we have to represent it. Then we have to determine the neutral axis. Okay. For rectangular, if it is 300, then it will be 150 and this is 150. But in case of unsymmetrical sections, we have to determine the neutral axis. Okay, that is this line. Okay. Now, P is given, that is 100 kilonewton, or you can write is 100 into 10 power 3 Newton. Okay, then area of the section, that is area of top flange plus area of the web plus area of the bottom flange. Top flange is how much? 300 by 60. Okay, plus area of the web is how much? 80 multiplied by the overall is how much? 400. 400 minus 60 minus 60 means 400 minus 120, it will be 280. Next, area of the bottom flange, how much it is? 100 into 60. So you have to determine the area of the section. So we have got 46400, that is 46,400 square. Then we have to determine the neutral axis. So this one you have already learnt in the engineering mechanics. Okay, SA and SD1. Okay, how to determine this CG. Okay, therefore, because I can't explain each and everything, what I hope you remember the unsymmetrical sections. What we do, if this is like this. So what we did is that, so this unsymmetrical thing, what we have done, we have divided it into number of parts. So by constructing the line like this, okay, this become one first component, second component, and the third component. So what we have done, we have determined the CG of this one. Okay, that is y equals to, the first one is how much? 300 into 60. The second one is 80. The width is 80 and the depth is how much? 280. And again here size is 100 into 60. Okay, three components are there. Therefore 300 into 60 multiplied by 30 means, here I have taken the reference at the top fiber. This is my y-axis and this is my x-axis. Okay, if you want you can take it from the bottom, it is up to you. Okay, now I will quickly explain this one. This is 300 multiplied by 60. One more thing, because most of the numericals are based on these things only. This is my x-axis. It is symmetric about y-axis, so I have taken at the middle. Okay, this is x-axis, this is y-axis. Okay, this is the first component. Okay, for first component the CG, and it is CG lies at this point, center point. For rectangular it is at center. For here also it is at this. Okay, and here it is this point. Okay, now the first one is 300 by 600, sorry, 300 by 60. Area is given, and this 30 means the total it is 60. From here it is 30. Okay, if you remember the formula, x bar equals to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Okay, y bar equals to a1 y1 plus a2 y2 plus a3 y3 divided upon a1 plus a2 plus a3. Okay, I hope you remember these formulas in your basic engineering mechanics. Okay, then what is the value of x1? X1 it is 30. Now a2 is what? The web. 80 into 280 multiplied by x2 is how much? 200. Why 200? The total depth is how much? 280. This will be 90. Total 200, correct. 200, 280, sorry. 280 divided by 2, it is 140 here. Sorry. 140 here and 140 here. Okay, it's 140 here, 140 here. Okay, and the CG is at this point. What is the difference between here to the reference axis? That is 140 plus 60. 140 plus 60, which is 200. Therefore, this is equals to x2. Similarly, the third one, that is the bottom flange. It is 100 into 60. And why it is 360? Because from here to the reference axis, the total is how much? 400. 100 minus, here it is 60, means this will be 30. Therefore, it is equal to 370. Okay. Now here it is a1, a2, a3 divided by a1 plus a2 plus a3. So we will get the axis, that is 156 from top and 244 from the bottom. How? The total depth is how much? 400 minus 156, which is equals to 244. Okay, this line is, from here it is 156 and from here it is 190, sorry, from here it is 244. Okay, so we have got this distance, and he has given this intersection of 50 mm. From here to this is 244 minus 50, which is equals to 194. So we have calculated the E value, that is 194 mm. Correct? Then we want the value of Z. Okay, as this is not a perfect rectangular and it is an unsymmetric structure, so we have Z equals to I upon Y. Okay, therefore we have to determine the value of I. Y value we have already calculated, so we have to determine the value of I. I is nothing but the moment of inertia. Okay, I equals to BD cube upon L plus A into x bar. Okay, this is the formula. So for top flange web, and from the this also I will explain quickly. See, formula what we have, I equal to BD cube upon 12 plus into y bar here. Okay, Now area B is how much? 300. Depth is how much? 60. Correct? Now area it is 300 by again 600. Now 126. How we have got this 126? Most of the people do mistake here only while calculating this one, and this one. Most of the people will do mistake here. This is the way maximum people do mistakes. So remember it very carefully. Now this is my CG. Okay. Now what is the distance between from this axis? Okay. Center of CG. Okay. Main CG. I will write this one as a capital G. Okay. This is my G1. Now what is the distance from here to here? You can see 156. Okay, minus, you deduct it here, 30. This is 30. Therefore 156 minus 30, 26. 156 minus 30 is 126. Very simple, but most of the people do mistake here. I will explain once again. From here to here, the total depth is how much? 60. It is, if you do it 30 and 30. Now what to do? This whole is how much? 156. This is 30. What you do? 150 minus 30, you will get 126. Correct? Web. Okay. If you take web here, we'll draw here. Okay, this is my CV. Okay, the total number is 140. 140 and 140. Now 80 multiplied by 280 divided by 12, that is BD cube by 12. Correct? And the area it is 30 into 280. Now this one 44. How we have got the 44? See this line, and here you will get some CG. Correct? Means if I show you in a bigger way, okay, my CG is somewhere here. Okay, this distance is how much? 156. Correct? If you deduct 156 and this depth is how much? 60. And one more thing, this is 140 and this is 140. Correct? 156 minus 60. Now this 156 minus 60, and if you deduct 140 here, you will get how much? 44. Okay, one second. So this distance will be how much? The 44. Okay. Similarly for the bottom flange, IXX or IYY, that is BD upon 12. This is area, and this 124. How we have got this one? Okay. How much it is? If I draw the diagram, okay, this is my main CG. From here to here, how much we have got? that is 244, correct? But I need from here to here. Okay, this distance is 60 means this will be 30 because the bottom flange thickness is also 60. Therefore, the 30, what you do, 244 minus 30, you will get 214. Okay. After doing all the calculation, you will get the value of I. Okay. 75 into 10 power 7 mm raised to 4. Now, after getting the value of I, here we have the different ZT and ZB, but in perfectly symmetrical structure, that is in a rectangular structures, ZB will be equals to ZT. But in unsymmetrical structures, ZB will not be equals to ZT. Okay, so we have to calculate ZB as well as ZT. How we will calculate ZB? That is I upon YB, here I upon YT. So we have calculated YT and YB. Therefore, ZT equals to I upon YT, you will get ZT. ZB equals to I upon YB, you will get ZB. Okay. So we have got all the things, only we have left with the loads, correct? So first one, what we have to do, we have to determine the dead load. Okay. So the stress at the center of this span, okay, and he is asking the stress at the top and at the bottom, correct? Therefore, mg, how we will calculate, that is WL square by 8. W how we will calculate, dead load. Okay, you take all the components self weight, that is 0.3 by 0.6, 0.8 by 0.28 plus 0.6 by 0.1 multiplied by density. Okay, you will get weight. Okay, that weight you take it, that is Wg, and substitute in mg, that is Wg L square upon 8. So you will get the dead load, the moment to dead load, that is how much it is there here. Okay, here we have done directly. So after what you do, just calculate the mg. Then we have to calculate the mq. How will calculate the mq? We have the formula mq equals to wl square upon 8. Okay, and he has given the live load. How much he has given? Okay, 2 kilonewton. What you do? 2 into span is how much? 8 meter upon 8. So we will get the value of mq. So we have got mg and also mq. Therefore, substitute in the formula, you will get the stresses at the top and bottom. Okay, this is the stress at the top and this is the stress at the bottom. So anybody having doubt here? Be first. Comment yes or no. Anybody having doubt? One thing, be careful in calculating the moment of inertia and the center of CG. While calculating the CG and while calculating the value of I. Anybody having doubts?
No, sir.
Okay. So the next problem is also the same one. Here in the next problem, that is fifth problem, we have he will be giving the stress at the top fiber and stress at the bottom fiber. We have to determining the pre-stressing force. Okay, this is another different problem. We will solve it. Okay, This is also the same. Symmetrical sections is there. We will see about this one problem. Okay, so we have left with the pressure line, thrust. Here also we have simple numericals. Okay, but these type of problems getting in the exams is around only 50%. Now, in the next chapter, not next unit, in the next chapter, this is most important. Okay, different types of losses. Pre-tension losses is there, post-tension losses are there. Mm, this is your second unit. So still I need 3 classes to complete your first unit, because if I do little bit hurry in the very first unit means it will be very difficult to understand you the further concepts. Okay, so if anybody having the doubts in the numericals, please ask, because if you won't understand these problems, then further you can't solve any of the numericals. So if anybody having doubts, you can ask. Others, comment your roll numbers and you can leave the class.